especially when you discuss about the global climate model. So basically, I got question about that, but I will keep that the question first. Please, those who still got question that relates about with Dr. Eliza presentation, please do drop your question through the chat box after this. Okay. Once again, thank you very much for the very interesting presentation. Without now, I would like to introduce our second speaker. Okay, our second speaker is Dr. Kogila Vani Annammala. She is a senior lecturer at the Department of Water and Environmental Engineering, School of Civil Engineering, Faculty of Engineering, University Teknologi Malaysia. She is also a certified professional in erosion and sediment control. Okay, this afternoon, Dr. Kogila Vani will deliver to us her lecture with title of Environmental Forensics. Okay, Dr. Kogila Vani, without further ado, I would like to invite you for your lecture. Over to you, Doctor.
All right. Thank you very much, Dr. Amirul, and also Prof. Halida earlier for the welcoming speech. Well, it's not like a lecture. I'm just going to share briefly about my research interests. So I won't be going too much in depth about the fine details or models or data analysis and everything. It's more like a brief introduction for environmental forensic and a step towards my lab to see what my research is about. So let me just share my screen here. All right. Dr. Amirul, is my screen visible?
Yes, I can see the screen.
All right. All right, so and also thank you for all the participants today for your time on being here. I hope it will be a well-invested time. My name is Kogila Vani, as Dr. Amirul introduced earlier. You can call me Vani. And a little bit about my research. I'm working on sediments and erosion-related studies. These are some of the collaborators that I've been working on, and these are the works today. The works that I'm going to share to you comprises of works that I've been doing together with these collaborators and with the help of my research scholars, my PhD, my master's students, and my undergraduate students. All right. So without further ado, I would like to jump into my the topic that I would like to share, which is about environmental forensic. Okay, another word for that is actually sediment fingerprinting. So if I say the word fingerprinting, so most of you guys might be relating it or thinking or having a thought towards crime scene investigation, you know, where there is these movies that you may enjoy or like watching. All right, so this is actually the same metaphor that I would like to bring upon that is related to the research that I'm going to share to you about. When we're talking about crime scene investigation, right, of course, it is going to involve all these gallant, handsome investigators with pretty and beautiful women investigators who's going to come into a scene of crime. Okay, the movie will normally start in a crime scene with the police officer being there, and then they'll be trying to find clues and information to identify the culprit with proof and evidence so that it can be brought into proper jurisdiction. So the movie or the storyline would go into finding on traces from the victim itself, from the site of the murder, surrounding area, and then there'll be patrolling that's going on in the city or in the urban area, finding something that is new or abnormal, looking high and low, talking to people, talking to contacts and connections, and then it will be a wrap. All right, here, this is the murder. This is how the murder took place. All right, so this is the synopsis of what you'll be watching or seeing in a movie of CSI Miami or any investigation movies. So this is actually the same thing that I am doing for the research called environmental forensics. But it's just that my crime scene is the environment. Okay, so the way environment talks to us is very different on how we human communicate. all right? There's a lot of subtle traces how the environment actually sends us the message of distress that we can actually pick it up to try to identify, to understand what is going on, all right? Just to bring you together to my view. So let's see, okay, this is the picture that I took when I was descending to land in Kota Kinabalu. All right, so I would like to open to the audience here today. What do you actually see from this picture? Apart from the propeller, what do you guys see from the picture? Anyone?
Can I give my answer?
Yes, please. Yes, please. Yes, please.
Yeah, I can see the turbid water down there.
The turbid water down there. Yes. So this is actually related to sedimentation, all right? So this picture is taken in Sabah, all right? The sediment issues is actually not only in Sabah, it is a global issue, all right? Sedimentation is a global issue that's happening worldwide. Why is this a major issue? Why is this so critical that we have to address it? All right, this is what we are commonly seeing in most of the areas around the world, all right? But this is what we expect to see and we want to see and we hope to preserve for the future generation, all right? So this coastal environment is a very sensitive and very important environment. Okay, for some who may not who may not know well about the importance of coastal environment, let me share briefly a few points, all right? So coastal environment is where the wetland ecosystem exists, where the coral reef ecosystem is there, seagrass ecosystem, which is also sustaining the fishing industry, aquaculture industry, forestry, and tourism industry. All right. As you can see at this coastal area, there's very beautiful corals and everything. Now, I would like to give you a scenario. What would happen if you cover the corals with a blanket of silt, sediments, and soil? Can you imagine what's going to happen to the corals down there at that particular ecosystem? I'm quite sure most of you guys might be aware of the term coral bleaching. All right, so it's the same as you bleach your clothes, you know. So your clothes come in clean and beautifully white. But this is what happens to corals. You know, coral bleaching. For those who know, this is actually a graveyard of corals, right? The death of corals. So what happened? What actually causes this? So this is the result of this, right? Excessive flux of sedimentation that is from the land towards the estuary, right? So this is where I would like to introduce about my research, which is on non-point source pollutant identification, all right? So point source pollution related identification is quite direct forward because you can actually see where is pollution coming from. But dealing with non-point source pollutants, you are dealing with unknown and uncertainties, all right? The method that I'm going to share to you is how to treat this non-point source pollutant as a point source pollutant. All right, this is where we are going to use chemical markers. Coming back to the earlier picture that I showed to you. So what I can see from that picture is I can see points for me to gather sediment cores, to take sediment samples and soil samples for chemical markers using phytoplankton as clues, all right? And then taking the whole area itself as a site, all right? As you can see, as I am sharing, I couldn't emphasize more on the effect of sediment and sedimentation. So now the question comes in like, why sediments? Why is it so important and crucial to understand about sediment? Okay, the picture earlier denotes and I shared about is the effect towards the coastal environment. All right, before it enters the coastal environment, the river system. Okay, what are the impacts of excessive sediments towards the river system? Okay, on aquatic life, it blocks the sunlight and it impacts on the growth and the survival of the aquatic fish, mussels, and other aquatic animals, all right? And on humans and infrastructure, it affects on the water quality for drinking, for reservoir operations, for recreational purposes, and it also can cause property damage and reduces the property value. Okay, it can clog stormwater pipes and storage systems, which can cause into flooding. So where is this sediment coming from? It's actually coming from the erosion process. So we are actually moving from the coastal line up to the land use, okay, towards land. When we're talking about erosion, we are talking about two types of erosion, all right? One is the natural process, which we do not want to talk about because we have to be thankful for the natural process. If it is not for the natural erosion process, we would not have this beautiful white sandy beach around to enjoy. What we are going to talk about today, when I'm going to share about this anthropogenic process that is accelerating on the erosion rate, thus creating higher sedimentation rate, thus causing all this problem. So what are the effects of excessive soil erosion? First, as I explained earlier, it kind of like increases the sediment flow into the streams, and then it affects the stream water nutrients, stream water quality, because as soil moves in, it is also carrying along pollutants, particles that are being accumulated and in the land itself. All right. So it is also causing depletion of soil fertility, decrease in agricultural productivity due to nutrient loss. Okay. And also it can increase in flood frequency and magnitude. You may ask, why do I care? Well, all these processes are actually leading towards eutrophication, which means increase of nutrient in the lake or river system, right? And then habitat loss, transport of pesticides, reduced recreational, reduced reservoir life, loss of productivity, and the list goes on, all right? And when we're talking about this, one of the most common and most widely discussed issue is on flood, right? This is an example that's in China, where it kind of like dozens were killed and hundreds of thousands of people were displaced in China floods. Okay, the magnitude can be massive. Okay, this is a picture in a village in Yangshao in Guilin, okay, southern China. We can see how the flood looks like. It's like in influx of sediment. It kind of like yellow and muddy. Do you know how it looks like prior to flood? This is how the area was. Don't have to look too far. Let's come to our own backyard. Let's look in Kelantan itself. All right, there was a major catastrophic event. Okay, it can be considered as the event of the decade, the flood disaster in Kelantan. All right, it caused more than 20 people were killed and billions of loss in damages right? So today, I'm going to share about sediment fingerprinting or environmental forensic. Okay, the question that I asked is, if I am going to tackle this issue, okay, the water is cloudy and murky. It shows that it is actually being washed down from land surface to the system. If only I can identify where is the sediment coming from, what portion or which is the tributaries or parts of the catchment that is contributing most sediment, so I can go to that particular catchment to do some remediation or erosion, sediment control, or flood abatement processes. Well, to some, it may sound like it's an ambitious fairy tale story. You know, it's such a big catchment. How do we do it? Let me share to you about the process and the research that I'm working on, right? So again, coming back to the example in Kelantan, this is the flood in Kelantan. This is my project in Kelantan. All right. The main aim and objective is to identify where is the sediment coming from. All right. And the target area is in Kuala Krai. If you see, this is the river morphology. Okay. It looks kind of like simple and easy. There is two main streams that's coming into a bottleneck kind of meeting point and such in an extreme condition with heavy flow and influx of water and structure failures and things. So this is where there is this spillage, all right, and a big flood occurs. So how do we do it? How do we go upon it? To make it very simple, first thing is we map the catchment itself, all right? The hypothesis is that we take samples from the different sub-catchments that is feeding towards the tributary, all right? Let's name it as source 1, source 2, and source 3. And then we take sample from the crime scene. Here in this case is Kuala Krai. And then we try to identify what is the proportion, what is the mixing proportion between these three sources. All right, so this is the theoretical approach of this environmental forensic. So now we go to the field, we take samples from most of the major tributaries. All right, so in real life condition, it is quite impossible for you to take samples from each and every catchments and tributaries that is feeding towards the main system. So what we do is we have these assumptions and we take the major tributaries, right? And the process involves into taking sediment samples and then processing it in the laboratory and then some statistical analysis. So when we're talking about sediment samples, we are working with metals, right? Metals, and it comprises from the elements from the periodic table, which you all might remember during your school times as well. All right, we take this as the source, or as I'm lost of words now. Okay, this is like an indicator. All right. So the hypothesis is, let's assume with the source 1, source 2, and source 3, all right, when I took the sediment samples, source 1 was very rich in gold, all right. Source 2, the property was very rich in silver, and at source 3, it was dominated by copper, all right. These are the three signatures that I can see dominating in the three sources. And then next, what I do is I've already collected samples from crime scene, all right. Once I've analyzed the sample, I noticed and I realized that that particular sample was rich in gold. So from this particular example, I can deduce saying that most sediments at this particular area was coming from source 1. All right, but this is a very simple analogy on how this process is taking place. But of course, when we're dealing with real life environment, we are dealing with very large catchments with a lot of tributaries. So what we'll do is we'll be using a combination of elements. All right, this is where the statistical parts will be coming and helping in. And apart from that, we need to know a little bit about the background, the presence of the is it naturally or is it anthropogenic, and what is the concentration and how does it impact on human health and things like that are some of the background information that we can put it in our notebook. All right, so I'm going to skip on the analysis part and I'm going to jump in straight to the results. All right, the question was, within the two tributaries, which tributaries or which subcatchment is contributing most sediment to the Libby catchment, to the Kuala Karai flood area. So the unmixing model kind of like shows that Sungai Lebih contributes 56% of the sediments and Sungai Galas contributes 44%. All right, from this diagram, it looks so simple. All right, now we know, then let's go to Sungai Lebih or let's go to Sungai Galas. But it's not as simple as it sounds, you know. Why? Because the whole catchment itself, the size that we are dealing with is almost 12,000 square kilometers. Duh, where do you start from? All right, the hindsight, the positive side of this particular approach is that it is very easy for you to fine tune, all right, go into a higher resolution of analysis. So taking an example for Galas catchment, why am I taking Galas even though the contribution is lesser, is because this is the one that I've already published. So I'm sharing a data of what is already been published, all right? So taking an example of the Galas catchment, okay, it comprises of a network of river system. So we run the model with the sediment samples and everything. We can know what is the fraction of the contribution of particular tributaries towards the sediment contribution at that particular crime scene, all right? And based on that, you can even fine tune. Okay, let's say if it is we are focusing on a Ningiri catchment, and that Ningiri catchment itself is on over 800 square kilometers. So what you can do here is you can further fine tune and increase the resolution of the analysis, and with statistical analysis, you can actually identify which particular subcatchment is contributing or dominating the sediment flux to that particular system. So at this current stage, okay, matching with the land use and history of the land use, you can actually relate what is causing that particular river tributary to behave such. And since we have identified from a very large system to a narrower system, mitigation process seems more feasible and logical. All right. So that is one of the approach. All right. Now the question is, okay, I've shared to you guys how to detect on sedimentation issues current. Okay, this is what is happening now, spatial distribution. But we want to know how does it or how has it has been through time. We want to go into temporal resolution. All right, so we want to go into historical records. To go backwards, we went downwards. All right, this is a picture that I took in Kelantan for a project, for my PhD students project. I think Dinesh is here listening to the talk as well, I think. All right, so we dug deep and everything. But I'm not going to present this particular research now because the results are still hot in the oven. We're still analyzing it. So I would like to invite all of you guys to hop on our 4-wheel here and let's take a road trip to Sabah, Borneo. All right, this is my previous project that we have wrapped up. So let's go to Borneo for part 2 of the research, where I would like to share about the historical output. All right. So again, we took the catchment. We took the Ulu Segama, Lahad Datu. It's in somewhere in Lahad Datu. All right. That particular catchment is the second largest river in Sabah. The first one is Kinabatangan. Right. So there was a similar research that was done as in the Kelantan project. So I'm not going to present on the sediment fingerprinting part on the spatial results. I'm going to present on the second part, which is on fallout radionuclide. All right. So fallout radionuclide means we're using radionuclide elements as indicators to date the sediments to know how it has been behaving through time. So some of the elements that we are working in, our lab is working with is on lead-210, potassium-14, and cesium-137. Right? So lead-210 and potassium-14 is a naturally occurring radionuclide, right? And its half-life of lead is about 22.5 years. And for potassium, it is about 1.25 gigayears. Okay, it's quite massive timeline. But then the input or the presence of cesium in the environment is actually not present naturally. Anyone from here can, or do you have any rough idea on where do you think the cesium-137 could originate from? Anyone? Apart from my research students. Cesium-137 originates from nuclear bomb and nuclear testing. All right. So some of you guys might be alarmed. Okay, we don't have that in Malaysia, but okay, this is the news, the bad news that I have to share. Even though it's not here, it is taking place somewhere in the Soviet and the Russian borders. The deposition has been recorded worldwide. All right, there's an increased mark of cesium deposition everywhere, globally in 1954 when it was first invented and been tested, and at the peak in 1963 before the treaty ban was signed, and the third peak is in somewhere in 1986 during the Chernobyl accident. All right, these 3 points of the Chernobyl, this cesium-137 deposition is being used as a benchmark for dating process. Skipping on. So this is the results of the core, the sediment cores that we took and we sampled it. All right. Skipping on the analysis, the boring part, I'm going to focus on to the exciting output. Right. The core that we have, about 1.6 meter, actually dated back to 200 years. But since we could not gather the land use information for 200 years, we gathered about 50 years of land use. Right. And this is how the trend of sedimentation looks like. All right, this is where it comes very interesting. This is where I'll be putting on my investigator cap. Right, I'll be asking the question of why, what happened, what's going on in this particular area, what's going on in 2000, why is it so high in 2010? All right, so here Come on, everyone, let's put on the investigation cap, all right? The land use history in Sabah, the one that we are dealing with, is related to primary forest that is being logged and being converted to agricultural plantation, and some are being left as a jungle forest reserve, all right? Instead of looking at the highlighted area, I would like to focus on the questions to you guys. To 1980s, all right? 1975 and 1988, according to the history that we dug up, that is the peak of the logging industry. Now, I would like to ask you guys. You have a primary forest, and this is the first time that you're going to log the forest, right? So you can see huge trees and a lot of logs, future logs, kayu balak, right? That is available for you to log. But then, why is the sedimentation rate at that particular time is very low compared to the very, very magnified effects in late 90s and 2000? Anyone, any idea why? But 1980s is the time where the logging industry is at its peak. But the erosion and sedimentation effects to the river is not as crucial or critical as how it is 2 decades ago. Anyone with any hypothesis? Anyone trying on the investigation cap? No one? All right. I don't have the right yes or no answer. All right. This is all our hypothesis. All right. The thing is, during 1980s, when the logging industry starts, those are the days where the heavy machineries and proper road systems and everything have not been developed. All right. The main way of transporting the logs were using river. So in that case, they could not harvest or they could not log the very large trees. They could only log the medium amount of trees because that is the only way that is easier for them to transport it down using river as a transport. Later, but towards the late 80s and 90s, that is where heavy machineries were introduced and brought in bulldozers, trucks, and things coming in, and then the road systems were developed. So that is where you can see there is an increase in sedimentation rate. And it keeps on increasing because of the massive land disturbance and conversion to oil palm plantations and things like that. Okay, this is how you correspond the information that you have about land use and from the laboratory information. So we are kind of like synthesizing, and we are working on like the CSI investigators, putting things, pieces and puzzles together. So we did the same research. We did it one in lower stream and one in the upper stream headwaters and the downstream of the river system. We actually noticed there is this similar trend that we observed upstream and also downstream. But what I would like to highlight is on the magnitude of sedimentation rate. Okay, it's kind of like almost 10 folds. Almost half. It kind of doubled, the sedimentation rate doubles. So the thing is, if the disturbance is occurring at the headwaters itself, the magnitude is being accelerated as it's being transported downstream. So now we have two stories already. We already know, especially at this current stage, which tributary is contributing to higher sedimentation rate. And now we know that through time, how is sedimentation rate is like. So now it will be very interesting, right? Through time, if we can know about what is the proportion of the sediment mixing. So yes, this is also possible to be done. With the same approach, partially, we apply it for temporal analysis as well. And we get this kind of data. All right, and coupled with the land use history, you can actually have a complete story. All right, not currently, a decade ago, because this research was actually wrapped up in 2016. All right, the data that I'm presenting is from 2010. So in 2010, there were two tributaries that are dominating the sediment flux into the river system. All right, 2 decades ago, there is more tributaries that is contributing into the sediment flux. Okay, how it was behaving almost a century ago. So you can see different colors here are representing different tributaries. All right. So at this particular time when this result was observed, if you would like to make drastic change through the particular river system by improving the sediment water quality and decreasing the sedimentation rate, I would suggest to target on these two areas first, and you can see some improvement in water quality. And then merging in, you can actually get in the story of each depth. All right. So those who are interested to know more about this, you can look up into some of my published papers on sediment clues in flood mitigations and how to determine the origin, transport, and degree of heavy metals. So what's next from this? We have identified the area. So next would be on erosion and sediment control plans, right? So this is how you can control. So apart from this research work that is on the riverbanks and river, I'm also working on the land.
Dr. Vani, very interesting presentation. I mean, very interesting sharing. So basically, I got question, but I will ask after this.
All right.
All right.
So the other sites of mine include in the land itself, I'm looking and working closely on erosion processes. Okay, I'm working in log forests, high conservation value forests, mature plantation, rubber plantation, and also in oil palm plantation. So these are some of my research focus currently, working with erosion, sediment related plants. All right. So that's about it for now from me. So there's much more to share. So instead of saying that's the end, I would say that's the beginning. And I hope that those who are interested or those who are in the same line of research, and we can discuss more after this project. All right. Anything, feel free to drop me a message or email at kogila@utm.my. So thank you very much. And thank you for your time. So
Thank
Dr.
you.
Andrew, it's yours.
Thank you very much, Dr. Vani, for your presentation as well. So very interesting presentation from both presenter Dr. Eliza and also Dr. Kogila Vani. Okay, they have finished their session. Now, I want to invite those who with any question, please come with your question. I got several questions within the chat box itself, so I will read through it. So the first question will be to Dr. Eliza.
With the data. So that is how I've been dealing with my data so far. Yeah.
Thank you very much once again, Dr. Vani, for responding to the question by Professor Fadel. Seems like we don't have any other question. I think we are at the end of our session this mid-afternoon. Thank you very much for the once again speaker and also the audience spending your time more than I believe that it will be close to 2 hour session. So once again, thank you very much. I wish all of you are in the good condition at your own location. So please stay healthy.
Stay safe.
Stay safe. Yes. Thank you very much.
Thank you very much, everyone. Bye.
Bye.
Thank you. Bye.